Hey folks, welcome to the monthly call. Today we have with us Emily, Dogan, and Salman. Today we have our third call in the MSAL JavaScript series. It is the last call. We had an outstanding call the previous month and a month before that with a lot of attendees as well as a lot of views on our YouTube video. If you have not attended that call, I would probably paste in the chat the link for those videos. Do check it out. But this call, again, exciting call. We have a new topic, deep dive on using MSAL Node to integrate Electron desktop applications. Desktop applications is very close to my heart. That's where I started my career, at least. So I'm really interested to see what folks have today. We would love to, hear back from you. I will be sharing a survey through the call. Please provide inputs on what you think went well and what other kind of calls you would like to have or what kind of topics you would like us to present. Like always, we will be recording this session, so let's be pleasant. And we will be putting the recording into ak.ms m365pnp. You can just go to that link. I'll be posting it in the chat window. And if you would like to keep yourself updated, follow these Twitter accounts, Microsoft 365 Dev and Azure AD. You will be getting updates about this kind of calls as well as a lot of other events that our team puts up. All right. Thanks a lot. Over to you, folks.
All right, Emily, you would like to start?
Sure. So our agenda for the call today is we are going to start with an overview of MSAL Node. We'll then get into some of the OAuth 2.0 native app best practices. Then we get to the really fun part of what you're probably looking for is how to enable single sign-on using these libraries. We'll then move into acquiring a token for Microsoft Graph, what it means to call Microsoft Graph, and at the end we'll have Q&A. We do have pauses for questions throughout the presentation, so feel free to put your questions in chat. You can write them down, hold them till the end. You can put them in chat. You can raise your hand and interrupt us if there's something that's really not clear. This is our path for today. So to start, we've been saying the term MSAL. MSAL is the Microsoft Authentication Libraries. We will focus this call on the JavaScript MSAL. We do have MSALs. We have other libraries for other languages. My focus is on JavaScript. I am the PM for the MSAL JavaScript team. What we're showing on screen here is our package structure. So when we say JavaScript, JavaScript is a large ecosystem. So we've tried to develop a few different ways to engage with this ecosystem. You can see on screen, we have our common layer. More importantly, though, we have our MSAL browser layer, which is what typically are single page applications we'd recommend that you use. That is a framework agnostic SDK. If you like a particular framework, we have React and Angular that you can use. The focus of today's call, though, is going to be MSAL Node. And MSAL Node, we do have a few different OAuth 2.0 grant types that you can do for it. We'll get to the codes and the specifics later. This is kind of an overview of the different things that you can use for MSAL Node and other things within the JavaScript ecosystem. So MSAL Node does support public and confidential client applications. And I will note, so Node is based off of the Node.js project. We keep up with the support schedule of the Node.js. So that would be the even numbered stable releases. If you're familiar with Node.js as a framework itself, we try to keep up with those releases there. That is our overview. And then we'll get into specifically using MSAL Node in your applications.
Yeah, so the demo application we're going to go through today, you can find this app on the repository here. And Sal will also share the link in the chat window. Essentially, you can just go ahead and clone this, register an app on Azure AD, and then just start hacking. In a bit more detail, you're going to need a Node.js version 14 or later, and an Azure AD tenant. You can easily get that through the Microsoft 365 developer program if you don't have any. And I just want to start with giving a brief overview of Electron as a framework and how MSAL fits into this. So Electron allows you to build cross-platform native desktop applications. The idea is that you write your code once and then you package it for different operating systems. And that allows you to do cool things like you could develop a UI framework and then UI and then use it on your Electron as your desktop UI. And then you could also deploy it to web as a single page application, perhaps. And an Electron application is essentially made up of two kinds of processes. There's a main process, which has access to your operating system and integrates with the native UIs of the operating system. And then there's one or more renderer processes. These are by default isolated, and they do not have access to Node or the file system. And these two kinds of processes communicate over what is called the inter-process communication, and they can exchange data between them through this way. So in an architecture like this, MSAL Node comes into play on the main process Node side. We essentially handle authentication in the main process, and then we share our authentication state with the renderer processes through the IPC channel. Now, let's go into a bit more detail about what are the best practices for desktop apps for OAuth. So most of this is outlined in the RFC 8252 memo. In summary, desktop applications must implement the proof key for code exchange, which is an extension on top of the authorization code flow. This is a mechanism that prevents authorization code replay attacks. So absolutely no implicit flow for a desktop application. And it is also recommended to use an external user agent for authorization requests. Traditionally, desktop applications, they've been using either an external user agent, typically the system browser on your machine, or an embedded user agent as a web view, perhaps, on your UI. So this has several drawbacks. One of them is that the host application running the web view would be able to access the credentials that the user enters, which is essentially the whole idea of OAuth, that the application shouldn't be exposed to the user's credentials, and that shouldn't be the application's responsibility. And it also makes it difficult for enabling single sign-on. Each time the user has to sign in again. So if you use an external user agent, a system browser, then you could just leverage the existing active session with Azure AD. And this is what we are going to use in this demo. As a redirect URI option, native applications, desktop applications could use one of the two redirect URI schemes here. The first one is private URI scheme, or sometimes called custom URI scheme, which is usually used together with an embedded user agent. Or you could use a loopback redirect, essentially the local host, for communicating with the Azure AD, with the IDP. Now, in theory, it's quite possible for a malicious application running on your system to listen for these channels and intercept the authorization code. And this is why we need the proof key for code exchange mechanism, which essentially, even if your authorization code gets leaked, it won't be able to use by the attacker. All right, so our happy path is single sign-on, but at this point, I just want to show you what the demo app we have here. So this is a very simple Electron application. I'm just going to go ahead and install the dependencies, and I want to show what we have here. It's the bare bones of a simple Electron app. We create a browser window, which is going to be a Chromium instance. And we load a preload script, which is a script that integrates the renderer process with the main process and exposes certain APIs from the main process to the renderer. And then we load the index.html file, which essentially serves as our UI. We have some native UI controls here. And eventually, we're going to have three event handlers: a login event, a logout event, and a get profile event. And step by step, we're going to add authentication here. If you look at the index.html file, this is a very simple HTML file with some bootstrap used as CSS framework. As an important aspect, we defined a content security policy here, which states that this page cannot run any script other than what is exposed from itself. So this is an important security measure that's recommended by the Electron documentation as well. You should definitely follow that when you're building an Electron application. And then we import some render.js script, which is essentially handling our UI logic. In my render.js file, I just assign certain event listeners, and then use this renderer API, which is coming from the preload.js, to exchange back and forth data between the main process and the renderer processes. Here we can see the channels we expose in the preload.js. And that's pretty much it. So let's go back to the slides, and our happy path will be single sign-on. And what we mean by single sign-on is that you have an active session. If your user has an active session with Azure AD, then when they try to sign into your app, they don't have to enter their credentials again. They will just be able to sign in without any prompts, unless they have multiple active sessions. In that case, Azure AD doesn't know which account it needs to sign in the user to. And you can actually bypass this by supplying some login hint to the your authorization request if you know the user's identity beforehand. So in a bit more detail, the process we're going to do looks like this. We have our client application, which implements MSAL Node. Using MSAL Node, we're going to create an authorization request and load this authorization request URL to a browser page. This will take us to Azure AD's authorization endpoint. If we have an active session, we can just get the authorization code back. Otherwise, we'll have to enter our credentials. MSAL Node will listen for this localhost and grabs the authorization code from the browser, and then exchanges it for a access token, a refresh token, and also an ID token from the Azure AD token endpoint. So all of this will be done by a couple of lines of code from MSAL Node's a new API called Acquire Token Interactive, and we're going to implement this step by step. So let's go back to our app. So I'll begin by installing MSAL Node. And what I'm going to do is that I'm going to wrap MSAL Node into a class with a simple interface. Let's call this out provider. We will also export this. And this class will essentially have three methods. We'll have a login method, a logout method, and a get token method. These will do async operations, so we'll also add our async keyword. And in the end, I want to use this in my main.js file. I'll instantiate this class. And then I should just be able to do something like login, and maybe I can access the account information provided by this class, something like this, to update our UI with the user's username. So how do we implement this? I'll go back to my out provider.js. Let's add a constructor here. Let's also have some member variables. An MSAL configuration object. We'll have a cache instance, and we'll also have an account object. And now in my constructor, I can go ahead and instantiate MSAL Node. So let's first import this. Go. First, we need to create a configuration object. And then we can pass this configuration to, there we go. Now, in my configuration object, I need to have a client ID and an authority at the very least. So I'll go ahead and do this. So now we need to register an application with Azure AD. So what I'm going to do is that I'll go to the Azure portal. I'll sign into my admin account. I'll select the Azure Active Directory service. If you don't see it here, just search for it. Then we go to app registration, create a new app registration. We'll call this MSAL Node demo. We want to sign in users in our own tenant. So this is going to be a single tenant app. And we will have a redirect URI of the type public client native, so mobile and desktop apps. Now redirect URI will be HTTP localhost. We'll go ahead and register this. We get our client ID, we get our tenant ID. We go to the authentication blade. We could see that the platform is configured and our redirect URI is here. We could look into the API permissions blade. We could see that by automatically, I've been added a permission for Microsoft Graph user read. This will allow us to read the profile information. We could do a bit more. We could add some optional claims to our ID token and access token to tell us more about the signed in user. So for instance, I could use the ACCT claim to tell me whether the user is a guest in this tenant or not. I could use the FWD claim, which will tell me the IP address of the user. Let's go ahead and select login hint, which is a useful claim that we could use in single sign-in and single sign-out scenarios. So I'll go ahead and add this. And then I'll just copy paste these guys back to my app. Here. All right. So this is pretty much, so in the configuration object, you could do more if you like. You could, for instance, configure MSAL to log messages. Is tell essentially what's happening at any point in time. So we could use some useful messages for debugging purposes. And yeah, so this will create our public client application instance and assign it to the client application. Let's also assign the cache. In this sample, we will have a in-memory cache. Then we could use this later on for adding and removing accounts. All right, so that's pretty much it about instantiating MSAL Node. Now, how do we implement the login methods? So as I mentioned, the API we are going to use with MSAL Node is Acquire Token Interactive. So I'll go ahead and create a try and catch block here. Just console log the error for the moment. And we could have something like const out response. And the API we are using is this client application, Acquire Token Interactive. So this API, let's take a look at what it does. It accepts a request parameter of the type interactive request, and then it returns a promise of authentication result, which essentially contains your access token and ID token and the account object. The interactive request type requires us to define an open browser function. This is essentially your implementation of opening a browser from your Electron application. And then you could also use a success template and an error template, which is some message that you could display to the user after the authentication is done or if it's failed. So I'll go back and I'll do this. I'm going to define a function here called const open browser. And here I'm going to use the Electron's shell API. So let's go ahead and import this. Go. And then I can just do an external URL. Now I need to pass this to out response. And then I can pass a success template. Let's say you are signed in. Close this window now. And then I could do a failure template. And I could use some HTML in this as well. So maybe something like, yep, that looks good. And I could also load the HTML page as a template. So for instance, I could do something like, let's create a new file. That's right. So now, and then I can go ahead and just read this file here. So maybe call this success template. It will be, so I need to read this file. So I'll go ahead and import this. And that'll be Eric. Now, you need to be absolutely sure of what is in this file template that you are using. You have to be sure that this is not running any script that you're not aware of. So be aware to properly sanitize this file. But essentially, after that, I can instantiate I can initialize the account with the account object from the authentication response. And let's also console log this. And that's pretty much it. So we can now go to the main.js and we can just call this. And then this account object will be initialized when the sign-in is successful. So let's go ahead and start this. All right, so here's my app. And I click sign in. The event fires. A browser window will open, redirecting to the Azure AD. And you can see that I have multiple active accounts, so I have to select one of them because Azure AD doesn't know. But I can bypass this by passing the username beforehand. I'm going to sign into this account. I've been prompted for consenting, so I'll do that. And then my template shows up. Now, the app will not automatically focus, but you could do this by using a deep link with Electron. Check out our samples in the MSAL repository. There are ways of doing this. For simplicity, I didn't implement this now. But essentially, if we go back to our application, we could see that the user is signed in. And we can see the identifier here. Now, when you sign in, you obtain an ID token, an access token, and also an account object. MSAL will log this for you. You could see the parsed ID token and the claims inside this ID token. You could also see the raw ID token and access token. When you sign in, the result is the ID token that you can use to customize your UI. But you should not use an ID token for accessing another resource. That is what we will do by getting an access token. So since we signed in, we should also look into signing the user out. So let's go ahead and implement this one. So logging out has essentially two aspects. First, you'll have to clear the application cache for anything related to the user. And optionally, you might also want to allow the user to end their session Azure AD so that the next time they sign in, they have to enter their credentials again. So this is quite easy. Let's go ahead and do this. For the moment, I'll just console log. And what I want to do is that I want to access the cache and use the remove account API to remove this account from the cache. And also set this to null. And now if I want to redirect the user to the sign out endpoint, I could do this. There we go. Essentially, this is your authority string plus OAuth v2 logout endpoint. So by default, this doesn't know which account it needs to sign out the user from. And you could bypass this if you like by passing a logout hint. So something like, let's improve this a little bit. We do this. Get our authority. and then we could use a logout hint. And this will be an optional claim we have in our ID token called login hint, a bit confusingly, but we could use this for logout as a logout hint. And okay, so let's go ahead and rerun this and try it out. All right, so I sign in. Select my account. Back to the application. Now I can sign out. Oops, I think something went wrong. Oh, we didn't call this logout. Sorry. Yeah, there we go. Okay, we need to rerun this again. And let me also use a login hint when we are signing in. I want to know which account I want to sign in, so I'm just going to use it. Let's go ahead and run this. So when you sign in, what Acquire Token Interactive API does is that it creates a loopback server on your machine and start listening on a random port. And then it receives the authorization code back here, strips it from the query parameters, and then stops the server. So now we are signed in, and we can just test sign out. Something went wrong again. All right. We couldn't access this for some reason. All right. We can debug this later on. But essentially, our application cache is cleaned out. Now, finally, let's look into getting an access token for Microsoft Graph. Again, I'm going to have a try and catch block. And the recommended pattern when acquiring a token is that you first try to get it silently using MSAL's acquire token silent. And if this is not possible, if interaction is required, you catch the error and then use an interactive method to get the rest. So let's do this. Exactly. Let's accept the token request in this method. And then just pass this guy here. And then we can return the auth response back to the main process. Now, if this is not possible, we're going to get an error, which is called interaction acquired out error. And let's go ahead and import this. There we go. Then we can just use an interactive method. And I'm just going to copy paste this code here, but we'll probably need to refactor this later on. So let's do that. We also pass our token request object to this method. And then we'll just return this. And if you have any other kind of error, let's just console log this for them. Okay, so if I'll go back to main, I can use this. Get token. I can pass here scopes I want to get a token for, which is going to be user read. I could also pass an account object for silent acquisition. And that's pretty much it. Let's assign this to token response and then console log this response. We could also hydrate our UI, the account object. And let's go ahead and run this. Sign in. Go back to the browser, sign the back. If you go to the application, we can now click to see profile. You will be prompted for this scope. Say accept. And then if you look at our console now, you could see that MSAL just grabbed a response from Azure. It will contain our access token that we want to use later on. And this is essentially how we get an access token. Now, you could use this token for calling Microsoft Graph. I will let Sal tell us about how to call the Graph API. But before that, were there any questions so far?
Let me see if I missed something from the chat. Yeah, one question was about how we handle refresh tokens. I think I missed there. So where and how does MSAL save the refresh token? The question was.
So MSAL abstracts away the usage of refresh tokens. As an application developer, you shouldn't be concerned with using refresh token. It will use it under the hood, and it will cache it in its own cache. So in this sample, we're using an in-memory cache, but you could look into saving your cache to disk. But essentially, the entire refresh token usage is abstracted away.
Is the cache configuration itself configurable by MSAL, or is that something you do via Electron?
Yeah, definitely you can configure it with MSAL. MSAL has a cache configuration options. You could look into our samples as well. We have several implementations to show how this is done.
Is the token itself encrypted at all, or would that be something that falls to me?
Yeah, that will be falling. So by default, it will not be encrypted, but you could look into encrypting the entire cache file yourself, or as Emily can confirm, MSAL can offer, MSAL is working on offering a better cache solutions, encryption solutions for doing this without involving the developer.
Cool, thanks.
I think we have also a question. Someone's raising his hand. Yes, go ahead.
Hi, I have a quick question. So here, when you're logging in, right, like it is going to the login microsoftonline.com. Like, can we see the network developer tools? My question is like, when it goes to login microsoftonline.com, it is calling the authorized client, right? So at that time, it's like prompting us to logging in. And when it's giving the 200 status code, so that means it's signed in. So it is giving the code based on the request that we are sending, right? Like if you're going to send like a request type as code, then it is going to give us the code.
True. All of this is abstracted away, but yeah, this is what MSAL does. It will take you to login.microsoftonline.com/authorize endpoint with some query parameters to customize that screen you're going to get. When you go to that URL, Azure AD shows you the login prompt, and
no, when exactly it gets authorized, like can we see that network tab, like for the one that you've developed?
Sure. Let's go ahead and try this. See if I have still it open.
I think you're gonna get it in the application. Oh, you might get it here actually.
Yeah, I'm not gonna get it here, but maybe I could do this again. Let's try. If not, we could always use Fiddler, but I don't want to do this right now. I don't think we're going to be able to see that.
Mm-hmm.
Yeah, but definitely check out our documentation. We have more details how this works, but essentially, as you said, you go to the authorization endpoint and you will see a screen there. The Azure AD will show you a screen, and if you pass that screen, if Azure AD is able to verify your credentials, this is what you will get, an authorization code back to MSAL.
Yeah, after this login microsoftonline.com, it is going to the auth token, right? To try to get the token. So first a get is going, and then a post is there to get the token.
Exactly.
Or the
authorization
code
first. You get the code first in the URL. There's a query parameter, and then MSAL grabs that code. Yeah.
In the response, we are having a code, and also when we are seeing in the cookie, right, in the application tab, that we can see that cookie is also generated. So does that mean that this is authenticated?
Yeah, that means that you establish an active session with Azure AD essentially.
But sometimes
entirely... Yeah, go ahead.
But sometimes what is happening is it's keep on looping through. It is like keep on redirecting to the page, that the localhost page that it has been developed. So I'm just trying to figure out like where we can see. And from the network tab, when I'm seeing the response, it says different message. But through Fiddler, actually, we are getting a different response though.
That sounds like a bug. You should definitely be able to get all the network trace on the Fiddler. I just don't want to use the Fiddler in the call, but it should be all there. Yeah, if there is a bug, definitely go ahead and file a bug, and we should take a look into this.
Okay. And another question, like, it works for me, like when I developed, and when I'm trying to give it to another developer, it is not working. In the app registration that for them, in their system, I try to log in and it authenticates. So when I check in the app registration, there is like single tenant, or we can even give just organizations and also personal account, right? But if, in that case, like,
Not for the single
what
tenant,
is the
but
reason that it will just work for one person? Because I'm the one who.
it's very difficult to, but we could definitely help. Like if you file a bug or with the in any of the support channels, we could help with that. But it's very difficult to know without looking at some network trace and your application configuration.
Okay. And the default redirect or callback path for the MSAL, is it like sign-in OIDC for the identity provider?
That depends on what redirect URI you assign. So it's mostly it's up to you what redirect URI you want to use. In some special cases, there's a set redirect URI. For instance, with our Electron app, we have to use the local host because this is how the acquired token interactive API works. It will start a loopback server and listen for the local host. But in a single page application, you have much more options.
Okay, and is there any reason that you used just HTTP, like in localhost HTTP and HTTPS, both can it work, or is there any restrictions over there?
No, it just have to be HTTP. HTTPS would, not entirely sure if it would be possible, at least not with the acquired token interactive API that we use. It will by default just listen for HTTP. So yeah, as far as I can tell right now, it will be just HTTP. But in a single page application, it's a bit more up to you. If you establish a HTTPS server to listen for, then you could use HTTPS localhost as well.
Thank you. And for multi-factor authentication also, will there be anything over here, or it will work perfect?
It is entirely up to Azure AD what it prompts. So if there's some conditional access policy there, you will be prompted for that. There are certain cases you have to handle the response in your code. We definitely have samples, so go ahead, check our code samples, and you will definitely find something about handling conditional access or different conditional access scenarios.
Sure. Thank you. Thanks.
You're welcome. You're welcome.
I think we have another question as well. Someone else raised their arm. Speak, please, if you have a question.
Yeah, so one quick question. So you're having to sign in every time you start the app. I'm assuming that's what caching would take care of as well. Is that correct? You would cache on the node side?
Not really. So we'll, if you have a valid access token in your cache, you just go ahead and use this. If it's expired for some reason, your ID token or access token, then you'll have to go to the Azure AD again. You might have an active session cookie with Azure AD, so you might just see a brief transition. But if you have a cache and if you save it on disk, you will see much less redirects, so to speak.
So you could attempt to do like a silent sign-in first, and if that fails, then you would have to show the sign-in page. Is that correct?
So in the single-page applications, we have MSAL browser has an SSO silent method, which essentially opens the hidden iframe to do all of this, so the user doesn't see any prompts. On the node side, if your tokens are, for some reason, if your tokens are expired, essentially, then you won't be able to use the tokens, and you'll need to do an interaction, and that will definitely take you to the authorization endpoint. But as I said, if you have an active session cookie, you're just going to get back to the application immediately after that.
Awesome.
Okay.
Thanks, Dogan.
No worries.
So let's get on with the session, and probably we can take more questions at the end.
Sure.
All right. Okay, so I'll let Sal to talk about how to call Graph?
Okay, we're using Graph SDK to call Graph API. We recommend developers to use Graph SDK rather than call the Graph API directly, because Graph SDK helps build high-quality, efficient, and resilient applications. It also provides a set of features that enhance working with all Microsoft Graph services, like embedded support for re-entry handling, secure redirects, payload compressions, paging through collections, create patch requests. Now let's go through the initialization. First, we must initialize a client instance of the Graph SDK. As we can see in the table, there are two different ways to initialize the client instance in your application. The first implementation is create with client options, where we configure a default middleware that allows the SDK to communicate with the Microsoft Graph. First, we must create an instance of a class that handles authentication. This class must implement the auth provider interface, and we will contain the logic of acquiring token. Then pass the class instance as an auth provider in the client options variable to instantiate the client. The second approach is create with options, where we pass an auth provider function in the options while initializing the client. In this case, the user has to provide their own implementation for getting the access token and refreshing the token. A callback will be passed into the auth provider function that contains an access token or an error. We will be implementing the second approach because MSAL will handle the access token and the refreshing token for us. And then let's go to the next page, which is how we call Graph API. After initializing the Graph SDK, we'll obtain an access token from MSAL with the required permissions, as Dugan showed in the code before. For example, let's use user read and pass the token to the Graph SDK and call the endpoint me to get the profile information. So let's go back to the code and see how we do all of that.
All right, let me switch to branches. Just a second.
Take your time.
Okay, you can all go away. You can do checkout at F.
So as you can see in the code here, we have a graph file. This is exactly how we instantiate it in the Electron application. We have a function called get graph client. We pass the access token that we fetched from MSAL. We instantiate the client and return the function. And then we go to the main.js. We'll go to the get profile. And as you can see here, we have the token request, which is basically getting the token with the reads. After this, we get the get profile function. We pass the access token. We go to the me endpoint to get the profile information. Let's run the app and see how all of this is working.
I think I need to install dependencies again.
Let's see.
And then run this.
So this time we're gonna sign in as usual.
Oops, we had an issue. Oops.
I think also we didn't. Yes, exactly.
Yeah,
You didn't.
Let's go ahead and grab these again. Oh.
And also, I think you're good to go. Yeah, sign in. Acquire token interactively again, redirecting. Pick the user, and let's get back to the application, see profiles, and then you get the data basically of the user who's there. You can get the token basically on signing in as well, because someone asked me in the chat where we basically pass the scope when you log in the login request, or you can actually basically ask for the token when you make a request to Graph. And that's it. Let's get back to the presentation again. And we have more links for more data details on our tutorials in the presentations. Now we'll take any questions if you guys have any question for us. If you want to use the chat and you would like to ask the question, we're here. If you want to use the chat, we're also available.
There is a question from Brit.
Yes.
You want to take it?
So in terms of using the browser, it's recommended to use the browser to sign in the user and to get your tokens, because the browser like you get all the security features of the browser, and at the same time you get like single sign-on at the same sense. Like you can easily get if there is an active session available. And if we use that, is more recommended to use this approach than using Electron basically internally.
So yeah, just gonna say that approach is possible if you want, and there's a sample in MSAL.js repo that if you want to see how it's implemented, but that is not a best practice essentially. Yes, you do get an access token when you first sign in. That access token, so when you're signing in, when you're using a token acquisition API, you'll specify scopes that you want an access token for. And if you don't specify anything, you will still get an access token. But that token is essentially the token for the user info endpoint, which is an endpoint to give more information about the user's profile, but that is not a graph token. So if you want a graph token, you'll need the user read scope.
Can you show us the code where the scopes are specified and how the access token looks like, please? Thank you.
Sure. So yeah, if you see here, we have every acquire token API from MSAL will allow you to specify scopes. Tell these are the scopes that I want, and it will try to get those. So all of those scopes should be about the same resource. So if you're, let's say you want to call your graph and you want to call your own custom web API, you can only get an access token for a specific resource at one time. If you want different access tokens for different resources, you'll have to use another acquire token call. You'll have to make another acquire token call. You can, though, prompt the user to consent for all the scopes that you're going to use later on in your application. So if you just want to simplify the user interaction, if you want to minimize the user interaction, you could do that. But yeah, essentially all of the acquire token APIs will allow you to specify the scope.
All right, you have your hands up. Go ahead, ask your question.
Yeah, so we have an application that we host on a website, and we're using MSAL.js, and everything works fine. We are also providing a download, like a desktop app download. We're using Electron, but we're loading it from that website. We're not loading local files. We're loading files from our website. And we like to get a better login experience, single sign-on, and all that stuff in that, when we're using that Electron app. So how can we mix MSAL.js that's in the single-page application and MSAL Node? Is there a way to use those together, like to somehow use MSAL Node to get some kind of token and then pass that into the browser via IPC, or do we have to have in our website, do we have to have two code paths, one that's when we're using it on the website and one when we're using it in Node or in Electron?
So there's off the top of my head, I could think of couple options you could go there. You could use the same application registration for your both web client and your desktop client. And when you're launching the desktop application from the web, I think you're talking about something like a deep link that when you click on it, it launches the desktop application.
No, it's just, so it's an Electron application, but instead of loading from file, we're loading from URL. So in main.js, we're calling load from URL instead of load from file. And it basically is a shell, but we use that because we want to access some system capabilities that you can't get when you're running in the browser. So for customers that want that additional functionality, hey, go download this desktop app that really just loads this website inside Electron.
I think you should be able to pass some identifier about the user to your Electron app when you're loading it from the URL. It could be, if I understand correctly, the user can sign into your web app. You'll have a unique identifier about the user, maybe some login hint as well, and session ID. And then you should be able to pass this to your Electron application. And then authenticate from there, and this should be essentially an authentication without any prompts if they are sharing the same application registration and if you pass a login hint. There's also a
well, so the challenge is, yeah, authentication works fine when you're running it from the Electron, but you don't get single sign-on for just the reasons you said, that it doesn't work in Electron. So what we would like to achieve is we can determine when we're running in Electron, do the authentication using the system browser, but then can we then pass some code using IPC to MSAL.js and then use MSAL.js to acquire an access token using that code that was acquired from Node?
You could also look into. We recently had we have a hybrid SPA flow, which is essentially you start authentication on the backend on the Node side, could be our web server. I think that also could be an Electron application, and you get 2 authorization codes: one for your app, one for your Node app, and one for your single page application or web application. And essentially, those both authorization codes will be usable. So that means you only sign in once, and then you get 2 authorization codes to use in each of your application. I'm not 100% sure if this would be applying, if there could be some cases that would make it impossible, but that could be another approach that you could look into. This is called the hybrid SPA flow. You would definitely find samples on the MSAL.js repo as well, and some documentation on it. But it sounds like an interesting scenario. If you want to go ahead and create an issue in the MSAL.js repo, that could maybe generate more discussion. It sounds like an interesting scenario.
Okay, thank you.
We have a question. You mentioned the access token expire in an hour. How long until a refresh token expires?
Yeah, I think
it depends as well.
It also, yeah. So access token is by normally will be 1 hour, but due to the continuous access evaluation or some CA policy, this could change. But the idea is that you shouldn't be concerned about the token lifetimes. The idea is to, whenever you need to call a resource like Graph or your own web API, you use MSAL. First, you attempt a silent token acquisition, and if that fails, do an interactive token acquisition. And MSAL should handle the token lifetimes for you, essentially.
I'll send you a document that explains like the lifetime of the access token and the ID tokens, because if you looked at our documentation, you'll find the details.
Sure. I guess the plain text aspect of that is kind of what's bothering me here. I guess you had spoken to the refresh token, encryption of that cache coming up in the future. But to what extent, I mean, it's a JavaScript application, right? So it's kind of easy to read anyway. To what extent is the access token and especially the refresh token protected from prying eyes on that system, given that, that's a key that's just floating somewhere that has the full or scoped authority of the user for that whole duration? So I get that you can say, revoke it if suddenly it's being used across the world. Okay, that's nice, but what about the same building? How susceptible is that to someone just scooping that and great, now they're me for 90 days?
So there are two sides to this. If you're talking about Electron specifically, the Electron, the authentication is handled on the Node side, and
sure,
that won't be exposed to the outside world. But it's possible that your desktop itself gets compromised. So if you're talking about that, yeah, that is possible. It could be that they could be able to decrypt your cache. If your cache is not encrypted, that's if you're saving it on disk, that will be exposed. So you should definitely look into encrypting it. There is possibly, the one thing I mentioned is that another malicious application running on your system might listen for the authorization codes, but as I said, this won't be used. This will be useless because of the PKCE, proof key for code exchange.
Mm.
And those are some of the
I guess, I mean, that's the JavaScript question though, right? Why you can't give secrets to, say, JavaScript programs running in the browser is because, yeah, you can encrypt it in the browser, but they can pop open the dev tools, read your logic for how you encrypted it, and they can see how you did it and reverse engineer it. So I guess if you're encrypting it on the client side, okay, you're saving the low level people just trying to read the value out. But how secure is that value really? That's I guess it's just a question that's generally flummoxed me about just desktop authentication anyway.
No, so are you sorry, this is not Don, but his teammate. Are you referring to using secrets in a client application, or is it something else?
Yeah, I mean,
so you don't
I'm
use
signing
secrets in a client app. You never use a secret in a client-side application. That's number one. Public clients never use secrets simply because you don't do that.
Yeah.
So Pixie is some way to get some of the benefits of the authorization code flow. So that's the answer. You don't use secrets in a client application because your client application will be installed in maybe 10 or 10 million desktops. So
which makes sense.
The second one is that, hey, can somebody look into my flow while it's happening? It's not going to be somebody. It has to be somebody who is an admin on the machine or has full access to machine. If somebody has full access to machine, the fact that MSAL's traffic can be seen is hardly that relevant because everything else is compromised at the same time.
Yeah. If they can install Fiddler, they can read it. Yeah.
Yeah. So the answer here is that MSALs basically rely on HTTPS and the standards that are available in the HTTP and the internet world out there to provide the necessary security. It's not beyond. It cannot do anything beyond what is available via, say, the HTTPS protocol. If you have Fiddler, if you are inspecting HTTPS traffic, yes, you can see it. But can a random person see it? No, unless they have access to your machine. And if they have access to your machine in administrator, you have a lot more things as a problems in your plate than just your app and the secret that it might be using.
Sure. But because of the nature, I'm just not that familiar with Electron applications. Because of the nature of Electron, somehow it's difficult to access its memory to say pull the secret out of it. Because I get through HTTPS, unless they've got something like Fiddler intercepting those requests, they can't see the token actually go to my machine. So unless I'm caching that thing plain text or whatever, they can't otherwise intercept it. But what's the security of them simply just, again, if it's a browser, I pop open the dev tool, stick a breakpoint on that line, and just read the value right out of the variable. So to what extent does Electron expose that? Well, I get the token's not a secret, but it has the ability, if I take that token, I can drop it in another request myself, and I've authenticated, someone else has already done the authentication. I now have that person's credential. I'm doing the operation on their behalf.
So the tokens, access tokens issued by Azure AD are bearer tokens. So you can technically, yes, use it anywhere you want. Saving the token, encrypting it when you save it, and making sure that you practice least privilege because you don't want very powerful tokens are advised because of this. The next set of features that we are building is called proof of possession. It's not available yet, but the idea here is that in those cases, the access tokens will also be bound on the machine that they were issued. That is basically to handle scenarios if access tokens are picked up from one machine and used in another one just because there are bearer tokens. It's a known issue to us, but it will require a lot of protocol changes and a set of hardware bound features that are available via operating systems and systems and Windows and Android and iOS. We are working on it. I don't know when we will be making it available, but we are aware of the problem. We are trying to fix it. Today, you want to make sure that if you're caching tokens, first of all, your tokens should not be very high privileged. If you have very high privileged scenarios that require very high permissions, please use it in your server applications that are not deployed on desktops on users. And number two, encrypt your token cache correctly. Think about it as how you can encrypt it and keep it up to date by using MSAL on a regular basis to re-authenticate users as you see fit.
Well, that makes sense. Thank you.
Thanks, Kalyan. I think you pretty much covered the important points there. So, any other questions?
One note there, as Kalyan called out, we are working on proof of possession. We have no public timelines or commitments available to that. If that is a particular thing that you or your company is interested in, feel free to reach out to me and I can see about including you in some of our or previews for features as we try to develop that. If you're really interested, we love people testing these features before they're available. So feel free to reach out to me about that if that's something that you or your company is particularly invested in.
Yeah, can you drop your email in the chat?
Yep.
I just typed it, but I realized I could just come back off mute again. Can you authenticate with managed identities? So, sort of like how I guess, I don't know if Visual Studio is doing anything with Electron, but, I know that occasionally I'm asked to re-sign back in. Can you use the managed identity on the machine itself instead of logging in with the credentials? The MSAL?
So managed identities can only be used for client credentials flow or app only flows. So you cannot sign in a user with a managed identity. Did that answer your question? Or
Yeah, that makes sense. Sure.
Okay.
All right. Thanks a lot, folks. Thank you for joining the call, and we would love to get your feedback. We use this to improve our call. The next call that we have will be on the next month, which is going to be the third Thursday, which is November 17th, and we're going to continue with our MSAL series. We will be having an MSAL Android call. So yeah, looking forward to you all folks joining us, and yeah, thanks a lot for the eventful discussion.
Thank you very much, Nandish. Thanks, everyone.
Thanks a lot.
thanks everyone.
Thank you, everyone. Bye-bye.
Bye.